Laboratory 6 is with Keil and it's for branching function delays. So we have these questions that we can look at. We're not going to go over them here, but if you look in the description below the like button, we'll have some download links where hopefully you can see the data sheets for our TM4, C123, and then we can answer these questions. So the data sheets, and we can fill these out. That's just for practice. But to go into the actual lab, there's a few things that we're going to look at first. First is the preparation. We're going to need our launch pad and access to our data sheet to do this. We're going to answer any questions in our pre-lab reading. Those are the previous ones. We can answer those. And now we're going to start this. So the purpose of this lab is to learn simple programming structures in C. We will also learn how to estimate how long it takes to run software and use this estimation to create a time delay function. We learn how to use the oscilloscope to measure the time delay. C software skills we will learn including masking, toggling, if-then subroutines, and looping. So for our system requirements, the system we know has, these are our instructions, has one input switch and one output LED. Shows the system when simulated as the switch is touched for figure 4.1, which I don't know exactly where it is, maybe it's included later. A negative logic switch means the PF4 signal will be 1, so a high voltage 3.3 if the switch is not pressed. So that means negative logic, switch is not pressed, our LED is going to be toggled high. And the PF signal will be 0, toggled low if the switch is pressed. So when we press the switch, it's going to go to 0 volts. A positive logic blue LED interface means if the software outputs a 1 to PF2 high, the LED will turn on, and if the software outputs a 0, PF2 low, 0 volts, the blue LED will be off. So in this lab, we want to debug our simulation and then run it on the board. We're going to make PF2 an output and PF4 an input. The system's going to start with our LED on. We're going to delay for about 100 milliseconds. If our switch is pressed, then we're going to toggle the LED once, else we turn the LED on, and then we're going to repeat steps 3 and 4. So basically, once we press it, we're going to delay for 100 milliseconds and then turn it on. And then it goes off, and then again 100 milliseconds. So this is an example of our simulation right here. The time in our simulator is 86 milliseconds, which would result in 100 milliseconds on our real board. So let's now go into our Keil lab. It's going to look something like this. Now, this is what the original lab looks like. I've commented it out for now because we're going to be writing our new code. So inside of here, what's given to us are these comments right here. We're not going to go over them. We have this. We've gone over this in previous videos in the playlist link below the like button. We have all of this right here. Now is where we get to the fun part. So we're making this. We have an unsigned long switch 1. This switch 1 is going to be the switch 1 on our board that when we press it and we hold it, the light is basically going to flash. So this is the system. It has one input switch. It has one output LED, though we don't need to define it here. So our global variable is just unsigned long switch 1. Now we have basic functions defined at the end of our startup.s. So these are our basic functions. We have the void disable interrupts, void enable interrupts, and these are just for our grader. We have void delay 100 milliseconds, and this is going to be a function that we will make use of in a second. And then we have void printf init, it's type void. Again, we'll make use of this function in a second. So in our main method, right here, we have our int main void. Inside of here, we have our unsigned long volatile delay. We have our TExaS init. We have this inside of here. We're going to activate the grader and set the system clock. And so basically our initialization goes after all of this right here. This is kind of given to us. And so we have our initialization. We have our portf init function, and this is what we define. So we can come down a little bit. Inside of here is our portf init. This is where we're going to activate the clock, allow the time to start, unlock the GPIO port F, allow changes, and we do all of this. Now, how do we get this? Well, this is gotten from our next additional reading part. So inside of here, it's going to say, in this notes, the I/O pin configurations are presented. The regular function of a pin is performed parallel I/O, input output. Most pins, however, have an alternative function. So PA1, PA0 can be either regular parallel port pins or an asynchronous serial port called for a UART. So we have all these different pins right here, possible ports that we can configure for I/O. We have a block diagram that shows how everything works. We have some more information about our microcontrollers. We have a diagram of the switch and LED interfaces on our Launchpad evaluation board. So we can see that PF2 is going to be linked with our blue. We have our switch 1 and switch 2 going inside of here. Switch 1 is our PF4, so PF4 needs to interact with our PF2. We have more Launchpad information here, and then we have our port F init function right here. And we have some references, but that's going to be it basically. So we can take this port F init, it's in the notes, and this is in the instructions in the description below the like button. Now we can come back here, paste it in here as this function. We're going to call it in here before our enable interrupts. After enable interrupts for our grader, we're going to be in this while loop. So our body is going to go here. First thing that we're going to want to do is delay this by 100 milliseconds once we press it. We know that when we press it, we want to delay 100 milliseconds. So this might be able to go inside of here. We'll test that in a second. But we have this dirty delay of 100 milliseconds where we pass in 1. We'll come back to just the 1 in a second. And then we have our switch 1 is equal to our GPIO port F data, where we set this right here. Now, if switch 1, because we're using negative logic, meaning if switch 1 is pressed, because again, negative logic, we are going to set this to alternate. We have this arrow function right there. And if we look at the notes, we get some more clarification on this. It's going to go from high to low. It's kind of like an OR. So going back here, we're using this high or low. That's going to be this, and it's going to flash the blue. Otherwise, so if it's not pressed, we are just going to have this state as blue. So coming down here, after we go through our port F init, we have our delay. And I just have some notes, comments about which LED color it is, so we can see that this is the blue one right here that we're using. Now our delay 100 milliseconds, we're passing in some unsigned long time. The following C function can be used as a delay. The number 133333 assumes 6 cycles per loop, so that's 100 milliseconds. So that's going to be inside of here. We have while our time is greater than 0, I is equal to this number means 100 milliseconds. While I is greater than 0, we're going to just do I is equal to I minus 1. So we continuously run through this. Once we break out of this, we subtract 1 from the time. Now the time that we're passing in is 1, so we're just going to basically run through this outer loop once. So inside of here, we can see that we're passing in our 1 right here. And that's basically our entire time delay. Now we can go into our simulator, make sure we go in here, debugger. If you have any problems with this, there is the first video in the playlist, link below the like button, that goes over, I had some issues, so it goes over that. Clean our targets for good measure, build our project, and then we'll go into our debug. We're going to go into the evaluation mode. It's going to have this logic analyzer, which should show us like an oscilloscope, but for me, it some reason didn't show. We'll click grade and you can see what I mean. So it's running like here, but it's not showing anything. I'm not exactly sure how to get it to show something, but it will pass all of the tests. We can see which one is pressed, our blue LED is flashing. We got a score of 100. Now let's try to change some things. So if we go back to our main function, we have this delay 100 milliseconds. Well, we really only want it if our switch 1 is pressed, right? So let's try to put it inside of here. If we put it inside of here, we can build a project by just doing FN7. We can go debug, go in here, and just click grade. So we got a score of 100. Now this is probably a better way, since the fact that we would want our actual delay only with this part. It doesn't really affect this if it's pressed too much, but it's good just to keep everything where it is. Now, what if we don't initialize this? So I'm going to rebuild this like this. We're going to go into our debug, and we're going to click grade like that. And we can see that it does not pass because when the switch is not pressed, we have an illegal output. So the PF2 should stay on, but it looks like it goes off. Move our debugger, we go into our code. I believe it's going to stay at 0 if it's not declared. So let's go back and leave this inside of here. We'll go out of our debugger. We'll build our program again. We'll go into our debug, press OK, and then grade this again. And now with this back in here, we should get 100%. Now let's go and set up our real board. Dealing with our real board, we're going to want to make sure it's plugged in to our computer. We're going to power it on with the debug, and it's going to look like this. Now inside of our actual program, we're going to exit out of our simulation debug. We're going to want to go into our options, debug, we want to use these stellarists right here, press OK. We're going to want to, just for good measure, build the target. We're going to want to load this onto the board. If there's any LED on the board, it should like kind of refresh it. So clicking load, we can see my blue LED has turned off here. We have our erase done, program done, verify done. Now we're going to go back into our debug for the real board. Press OK here. And now we're in the debug for this. So to start this, what we're going to do is we're going to press the reset button. So first we press the reset button. See the blue LED comes on. Now if we press the switch, it should turn off and back on, right? And we can see that it flashes. So every 100 milliseconds, this blue switch is going to flash. Now, if we wanted to, we could easily change the color. We could easily make the time delay more or less often. But that's how we would do this lab. And that is how we would code out this board to flash our blue LED. If you want more computer engineering, microcontroller stuff, embedded system designs, it'll be in the playlist in the description below that like button.